All right, so we can get started now. Hello, everyone. Welcome to Always Coding, our weekly Hacky Hour. In case you didn't notice, Hacky Hour is just a pun on happy hour, so feel free to grab a snack or a drink. No judgment on my end. I'm going to have some coconut milk chocolate while we do this. And we're just really excited to have a really great community join us and actively participate in asking questions or offering feedback, or anything else you'd like to discuss in relationship to computer vision, Always AI, sharing your projects. We're just super, super happy to have you here. A little bit about me, I'm Komal Devjani. You might have seen me at our other webinars or our other Always AI events. I'm a developer advocate for Always AI, and I work with developers to engage the community into further using Always AI and learning more about how you're leveraging computer vision for your projects. And I'd like to hand it to Eric to introduce himself as well. Eric?
Hey, I'm Eric VanBuhler, one of the engineers at Always AI, and work primarily on the EdgeIQ Python library and kind of the runtime environment on edge devices. And yeah, I'm excited to show you guys how to get up and running on an edge device and stuff. So awesome. Yeah, that's what I got.
Awesome. Thanks, Eric. Yeah, just really quick to set things up for today, I want to walk everyone through sort of showing them how to launch or install the Always AI CLI and how to get started with the real-time object detector locally on your Mac device. You can also do it for the PC, whatever it is you prefer. And then I'll hand it over to Eric to show you guys how to set up an edge device, and then he's going to show how to run our SnapShot security camera app, and I'll share the GitHub repo for that as well. So with that said, just FYI, we want this to be a super interactive conversation. So if you have questions at any point, feel free to raise your hands. I'll notice if anyone's raised their hands, and I'll unmute you to ask your questions, and we'll answer them live. Oh, hi, Steve. So just don't hesitate to ask any questions. At the end, we will open it up for open Q&A. So, again, raise your hands, and we'll just kind of call people out and unmute them. So with that, let's get started. If you haven't done so already, what you want to do is go to alwaysai.co, and you want to click login. And hopefully all of you have already set up an account, but if you haven't, you want to click sign up now and then go through the process of signing up and confirming your account. I've, of course, obviously already set up my account, so I'm going to just log in. And once I've logged in, it's going to navigate me directly onto my dashboard. So here I can see all of my projects, my models. This could be any models I've uploaded. Collaborators, so this could be any team members you would like to work with on a computer vision project, and you can register your device as well. So as you can see, I've already set up a project for a Hacky Hour, but if you would like to set one up, you can just click Add Project, and then specify a name for your project, specify which of the computer vision primitives you'd like to use for this project, and then click Create Project. So I'm not going to do that because I've already set up our project for Hacky Hour 1. And once you navigate into your project, you want to click Download for Mac OS. And if you have a Windows, you want to just click Download for Windows. Now, just a really quick side note on the download piece, we're working really hard as a team to get certified for Mac and PC, so that you don't see this pop-up over here that says, this can't be opened because it's from an unidentified developer. I just want to promise you that it's totally safe to download it. I've downloaded it, nothing weird happens. It's not a virus, I promise. But just a quick workaround for that is you want to click this and click Show in Finder. And then from there, you can open the app directly from your Finder. And then this will give you another pop-up that allows you to open the app, and then you can go from there and just continue to install. And then for Windows, it looks something similar where it says something like, oh, this is an unrecognized app. Running this might put your PC at risk. I promise you, it's not going to put your PC at risk. You want to just click Run anyway so you can enjoy the benefits of Always AI. Okay, with that out of the way, so we're going to go back to the projects. And the next thing we want to do here is add a model. So I've already added the Coco model here, but just so you know, you can go directly to the model catalog or add the models directly by clicking this add model button here, and then you can navigate to the model catalog here, and we're going to go into object detection because that's the model I want to use. And then from here, as you guys know, some of you probably already have met me and you know this is my favorite model. So we're going to go into the Coco model, and then select a project, and then add to project. So as you can see, I've already added this to my project. Now, what you want to do after that is go back to your dashboard and into your project. And you want to copy this command here, AI app configure, and go into your terminal. I'm going to create a new one here so you guys can see. And then I have created a directory here, always AI directory, which I'm going to go into to load this app. And then I'm going to add my command that I copied from the dashboard right over here. And then, do you want to save this locally? Yes, I do. And then from here, what you want to do next is go back into the model and make sure you've downloaded the model. So you want to just click copy into your CLI command, paste this here, and then this will pull the model from Always AI. And the next thing you want to do is go into your app.py files and specify this model right over here. So this is, I've already opened this up, so this is the app.py file. And you want to specify this model name right here where the quotes are. And then with that said, we're going to do the AAI app install back into our terminal. And that's going to fetch the model. And then from here, we want to do AAI app start. Takes a couple of seconds, and then you want to just take this, copy the link you get for the streamer, and go into your browser and paste the streamer link. And here we are. Hopefully this can identify some of the house plants I have, which I have no shortage of, and my cell phone as well. Right? So that is how you get the real-time object detector running. And I noticed that there's a lot of questions that I've already seen. Some people are saying, I was looking into models of Always AI. Very cool. Thank you, AB, for checking us out. And then AB also said, any pointers where I could look for, I could then try to Dockerize it to use it. Eric, any ideas how to answer this specific question?
Yeah, I was actually just typing out the answer to it. It's a continuation. So AB is asking about models that detect things in 3D space. Okay. And we do currently have support for the RealSense camera, which has, you know, you can get your regular camera feed and a depth feed coming back. And along with that, we have planned support for the OAK-D, which is coming from OpenCV. But currently, we don't have any models that will specifically work in the 3D space. So I think we'll be looking into that in the future. But right now, we don't have any in our catalog. And I think as far as looking for some that might be out there, I haven't really looked myself, so I'm not sure. But I was just going to say, we should send out the Discord link. So if there's any kind of continued discussions, we can kind of carry them on over there. Some of these questions that maybe we need to look into a little bit more. Easier to discuss there than try and squeeze into an hour segment. So okay. It's definitely an interesting space, though. I mean, it's really getting a lot of people talking about it right now, the 3D and spatial space. So. And we did just do a webinar on some of this, on the spatial cameras and stuff, which was pretty awesome.
Yeah, I can actually share the link to the YouTube video for the webinar so you can have a look too, AB. Does anyone else have any other questions with respect to setting up and running the real-time object detector locally? Just feel free to raise your hand. Okay, Sehul, all right. Hi, Sehul.
Hey, can you hear me?
Yeah.
All right, perfect. So hi, and you know, I think we have been talking on LinkedIn, exchanging some messages
Yeah.
since few days. So thanks for that. Thanks for the clarifying my questions that I had. I have a question. What is Edge IQ? Like, what is that part in the Always AI domain? Like, and how do I use it? Like, I don't understand that part, because I've run your sample projects. I've run even on Edge devices, Jetson Nano, but I don't understand like how Edge IQ is or what exactly Edge IQ is.
Sure. Yeah, that's a great question. I can take that one, Komal. So Edge IQ. So if we kind of look at the platform as a whole, there's a lot of different facets to like what we do in terms of like the development tools we have, like the CLI and stuff like that. So Edge IQ refers specifically to first of all, the Python library that we've built for working on edge devices, single board computers like the Raspberry Pi. And additionally, it refers to the Docker container that we build and that acts as the runtime environment for Edge IQ. And basically, it has a lot of dependencies that we've built out, some drivers for support, different cameras like Intel RealSense, the Neural Compute Stick. All that's kind of wrapped up in that Docker container, Edge IQ Docker container. So I don't know if that added any clarity to it for you.
No, it did, and thanks, Eric. Thanks for clarifying it. The other question that I had was, I did download it. I think it came with the Always AI when I downloaded the Always AI CLI, and I see that there has been an update since then. Correct me if I'm wrong. And then my question is that how do I update it in my computer? Like, how do I update to the latest version?
Sure. What system are you on right now? Mac, Windows, or Linux?
Mac.
Mac. So you can follow the instructions that Komal did, and there are a couple places on our website you can find the Mac installer. So if you download the latest version and install it, it will just do an update on the version you currently have installed, and you'll have the latest CLI and Edge IQ versions.
Okay, so I can find the documentation of how to update it then.
Yeah.
Okay. All right. Yeah. Good to know that there is one. Thanks.
Yep. No problem.
Okay, Eric, we have one more question from Aman. He said, sorry, I joined 5 minutes late, no problem. How do I set this up on my Linux system? And he's like, we actually didn't discuss how to set this up on the Linux. We only discussed how to set it up on Mac. Would you like to address this one as well, Eric?
Yeah, sure. So I actually work on Ubuntu most of the time. So I'm pretty familiar with this. So right now we have the installer for Mac, which Komal showed, and we have a similar installer for Windows. On Linux, we don't have an installer built yet. So what you'll do is you actually want to use npm to install our CLI at this time. And the reason we haven't built an installer out for Linux is that the Docker support on Linux is much better in terms of interacting with hardware compared to Windows and Mac. So to run locally on Linux, it's much easier to just use Docker and run that locally. So if you have Docker installed on Linux and you install the CLI, you can run Always AI apps in the Edge IQ environment on your Linux machine. And I can share my screen and go to the docs real quick or if you want to point it out, Komal.
Yeah, sure. So I actually have already posted that in the chat, but I can share this as well here. So this would be, so once you go into our docs, you can go into development computer setup, and then you can select Windows, Linux, or Mac. And here you can follow the instructions of how to set up on Linux. And I've also shared the link in the chat, so I hope that's helpful, Aman. He said, got it, thanks a lot, sweet. All right, and then we have one more question from Leonardo Cohen. So he said, what might be available for license plate detection and reading and facial detection and tagging? And his next question is, can we, assuming we have access to the training models, develop something where we can teach system to recognize specific individuals? I think those two are pretty loaded questions. Eric, would you like to take those as well?
Yeah, I can take a stab at it. So I think that we do have a model available for license plate detection. I think that was I think Jason and Lila were working on that. Do you know, Komal?
Yeah, I think so.
So we can share a link to that in the model catalog. I haven't seen it in action, but I've heard about it. So I think it's pretty awesome. And let's see, reading and okay, and facial face detection and tagging. So yeah, so we do have actually several models that do face detection. Um, right now, I'm not sure exactly what you mean by tagging, but you might be referring to uniquely identifying different faces, which would kind of fall under facial recognition. And currently, we don't have any functionality for that piece. We do have some tracking that will let you, once you've detected a face, follow that same face around uh, and determine that it is the same face. But we don't have anything really in the facial recognition realm. You can build in other third-party libraries into the Always AI apps. Always AI apps. We have a workflow for that, and that way you could bring in facial recognition if that's something you're interested in. So let's see. Can we, assuming we have access to the training models, develop something where we can teach the system to recognize specific individuals? So yeah, so that's kind of more along. So when we look at this, there's a lot of these models perform detection, which means that they're going to detect like a car or maybe a specific car that it's been trained for. And then there's recognition where maybe you're comparing against, like you have a database of cars and you can determine a car based on comparing it in that database. I would see that more of like a recognition kind of a problem. So as far as recognizing specific individuals, you kind of have to either train your model specifically to do that, or go into the alternate, like other algorithms that fit into the recognition space, which isn't really what we cover right now. So if you wanted to train your own model, you could do that. Might not be the best way though. I'm not super familiar with that field though in particular. So feed more than one camera into a single powerful server and process those feeds with different detections. Yeah, so I have, so EdgeIQ, it makes it easy to basically take inputs from a bunch of different cameras. So you can build your app in such a way that you're taking like IP streams from multiple cameras. You can design it so that it can handle them asynchronously in case one disconnects or something like that. And I think we have some example code on that. I'll have to look around on GitHub and see if I can find that. Maybe later in the Q&A session, I'll dig around and see if I can find it and put it up.
Sweet. Thank you, Eric. Okay, any other questions about setting up? All right, we have one more raised hand. Sale, okay.
Hey, this is a question for Eric. Eric, I have tried the pose estimation model before, and and I've deployed it on the Jetson Nano. And and this was, I think, a month and a half ago when when there was a webinar where when you guys did a webinar back then. And what I found that, as soon as I deployed it on Jetson Nano, it was the inference was very slow. It was almost like moving in slow motion. So I was just wondering, like, has any changes been made to that since then? Or, are you aware of it, or?
Yeah, and actually, if Steve is allowed to talk, because I see him up there too, he might actually be more familiar with that. But I'm not sure. I'm imagining you're using the model titled Human Pose. I think we have a pose estimation model built for TensorRT. You might get better performance out of that, but I haven't done it myself and measured the performance, so not really sure on that. Okay, and we're getting comments from Steve in the chat thing. So he says, update the container to the latest EdgeIQ 0.14.2. So maybe we have some update. I think that's where the TensorRT updates, they came in that version.
Okay, so I do need to update my EdgeIQ version then. That's
yeah.
Okay, all right, thanks.
Yep.
Sweet. Okay. Any other questions before we move to edge device setup?
_pose_nano. Hey, Komal, we've got a group of developers, so I have actually the pose estimation person here. So Andres, why don't you go ahead and answer the questions?
Yeah, if you update your model to human _pose _nano, and set the engine to TensorRT, that should right away give you a human pose model that's being inferenced on the Nano's GPU, which should be significantly faster than what you're seeing.
Yes.
Oh, okay.
And then you also have to have in the environment not just 0.14.2 as the edge IQ, but it's got to be, I think, nano dash.
Yep, yeah, nano dash. Let me check here.
But your experience was the correct one. That's why we've updated it and so forth.
Okay. Would it, will it be okay? Is it possible for you guys to do maybe like a post or a blog on that, just to update, how to do it on Mac, Edge IQ, and
would it be possible for what?
Can you say one second, guys? Let me go ahead one more time.
Would you be able to do a blog post on your, on the site about how to update the Edge IQ, and then, how to do the pose estimation, like what are the changes I need to make? Like you said, it should be nano, right? In the accelerator or somewhere. So
yeah, and then we'll do that, but I think ahead of time, I believe we have your email address, correct?
Okay. Yeah.
I think we'll get you information out right away as opposed to waiting for a blog post on
that. Perfect. Yeah. Okay.
And, yeah, no, that's really good information. We'll probably put it in the docs a little bit more clearly.
Yeah, and we'll put it in the docs more clearly. Yes, as I said. All right, thanks.
Yeah.
Sorry, we're gonna.
Thank you, guys. Yeah.
We're gonna mute up here. We're a little
Thank you, Steve, and thanks, Sahil. Okay, all right. I think we're ready to move into edge device setup. So I'm going to hand it over to Eric for edge device setup and showing how to run the SnapShot security camera app.
Cool, thank you, Komal. And yeah, that was awesome. We got the whole engineering team over there shining. That was fun. So let me share my screen here. So we can get started. So yeah, so now we've seen how to install the alwaysCoding tools on our laptops. I'm going to demonstrate how to get the Edge IQ environment installed on a Raspberry Pi, and from there show how to deploy an app to it. So yeah, let me get situated here. Answering some questions in the background, of course. Cool. And share. There we go. Cool, so hopefully you guys can see my screen, and I've got a little other video feed here in the corner, which might be kind of small, but just wanted to show the Raspberry Pi. So I have a Raspberry Pi 4 with the Pi camera module attached, and this nifty little tripod thing, which makes it way easier to point the camera around. Before that, we were just kind of holding them and using twist ties and stuff, so it's definitely an upgrade. From there, yeah, so the first step to kind of getting started on this is to head over to the docs. So I'm just at alwaysai.co. Head over to the docs, and we have a section called Working with Edge Devices. And this page has instructions for a few of the main devices that we support, one being the Raspberry Pi, another being the Nano that we've talked a bit about, and then we have some generic instructions as well. So for the Raspberry Pi, the first step is to download the alwaysAI version of the Raspberry Pi OS image. And the difference between the base Raspberry Pi OS image and ours is that we've seen that, and for anyone that's set up a Raspberry Pi from scratch before will be familiar with this. It's kind of a manual process where you plug in a monitor and keyboard and work through with some configurations and stuff like that. And what we've tried to do is make it more of a seamless process where you can set it up in a headless manner by just kind of plugging it in, booting it up, and connecting it to your network. So the first step is downloading that OS image. And then I've already done that because it takes a few minutes. I didn't want people to have to wait. And then from there, we flash the OS image on a micro SD card. So I just have a a 16 gigabyte micro SD card. You might want to do 32 gigabytes if you're buying one new, just so you have a little bit more space. And then I can just plug the adapter into my laptop. And to flash the image, we recommend using Buehler Etcher. I've been using it a lot. It works really well. There are other tools out there, so it's not the only one by any means, but it's super easy. You just go select the image that was downloaded. From there, it looks like it already selected the correct device. You just hit flash. Now, this process also takes a bit of time. It took me like 17 minutes when I ran it earlier. So decided not to make everyone sit and watch the bar go across the screen. So if you're following along and you're getting behind because you're waiting for these steps, we'll have plenty of time, I think, as we go on for you to catch up when we're doing more Q&A. So don't worry. And there are plenty of instructions to guide you as well on the website. So I'm going to eject the card and plug it into the Raspberry Pi. Cool. So now we just need to power this thing up. And so how we're going to connect it to the network is by using a tool called Buehler Wi-Fi Connect. And so what this tool does is it starts up a Wi-Fi network on the device that we can connect to. And from there, choose the Wi-Fi network we want the device to connect to that will be working on it. So let's take a quick look. We'll give it a minute to boot up. So sometimes it takes a minute for it to come up on this, but what we'll see is that when we look at the networks, we should see the Always AI Connect network come up, and then followed by the host name. And of course, it didn't come up. Maybe I rushed it. It's a little bit annoying because it only refreshes the Wi-Fi networks. This being Ubuntu, only refreshes kind of periodically, so I might have to force it. Sure, there it is. So we can see it there, so it should be refreshed up here now. Cool. So we'll
Eric? Eric, you still there? Sorry, guys. I think Eric's screen might have frozen.
Komal, you have to give him a second. I think he just killed his Wi-Fi network.
Okay. Yeah, makes sense.
We'll be right back. So sorry about that. We're experiencing technical difficulties here at Always AI.
So yeah, as I mentioned earlier in the call,
I should have realized that disconnecting from the Wi-Fi would kick me off the call. These are the things you learn. So anyway, I'm not sure. It must have cut off when I was disconnecting from the Wi-Fi. So if you missed that whole thing, there's a picture here that explains exactly what I just did. So what I did was a prompt came up and let me choose which Wi-Fi I wanted to connect to. And from there, I selected AINet, which is the network I'm on, and put in the password, and then the device kind of resets its networking and comes up. And the default host name of the device is always AI. And so I can wait for it to come up on the network by just kind of pinging it. And we see, look at that, it's already up and ready to go. So we are ready to use this device with an Always AI application. And I guess I have a window up.
Eric, can you share your desktop?
Oh, I'm not sharing. Okay, that's right.
No.
Thanks, Steve. How do I get back to the... All right. Can everyone see my desktop?
Yep.
Awesome. Okay. So I will just repeat the last step that I did. I just pinged the device to see if it was up on the network and saw that we were getting the pings back. So the device is up and ready to go. I don't recommend setting your device up when you're on a video call. Apparently that's not, not the right method. But we're there, we've got it set up. So the next step is we can head over to the GitHub repo for the SnapShot security camera. And is that in the chat, Komal? Or I didn't check to see if you added it there.
Oh, good call. Let me add that here right now.
I can do it as well. But this is up on our GitHub too. And we have plenty of example apps up there for you to take a look at if you just want to kind of explore and see what's out there that go beyond what our starter apps do. Because our starter apps are intended to kind of show you a basic usage of like one of the fundamental pieces of our computer vision library. And so this app takes the real-time object detector that Komal showed and adds a few features that might be interesting if you're interested in building a security camera app. And we can take a quick look at the source to get an idea what the differences are. So for the real-time object detector, we just got an object detection object and then loaded it to the DNN engine. In this case, we're additionally getting a centroid tracker, and the centroid tracker enables us to determine that if an object detected in 2 different frames are the same object. And it does that purely by the distance between the bounding boxes. So if you can think about it, if you have 4 cars in one frame and you have another frame where those same 4 cars are detected, you could look at which bounding boxes are closest to the bounding boxes in the previous frame and match those objects together. That's what the centroid tracker does. And in this case, we're going to use it to determine that a person that walks into the frame is the same person as they walk around. And you'll see it in action in a few minutes. The next piece is if we go down to the main loop detection, what we'll do is we'll read a frame, detect objects, and then you might have seen when Komal ran it, there's quite a wide array of objects that we can detect. So we'll just do some quick filtering and filter only for the people that are detected, and then enter those detections into the tracker. And the tracker will maintain a dictionary of our current tracked objects so that we can do some logic that will take advantage of that. And what we're doing here is just determining if new people are walking into the frame or if they are exiting the frame. So what we'll do when we have a new entry is that we just save a picture and then we post a log to the streamer. When someone exits, we just post a log. And we'll see that when we pull up the streamer. The streamer being our kind of visualization tool that lets you see what the device is seeing, and it just pops up in your browser. So the first step to getting our app going, and actually, yeah, let's go ahead and clone the app. Clone the repo. There we go. So now we're in the repo. So now what we need to do is go to the dashboard, just like Komal showed, and set up a new project for this. And I already have a project there because I was messing around with it, but I will delete this. And we'll just make a new one for example. So, and we're going to start from scratch this time because we already have basically a fully configured application. So we'll basically make a blank project on our dashboard to work with. So from there, what we will do is we can run AI app configure in this directory, and it'll show all the projects that we have to choose from. So we'll choose the SnapShot security camera, and then we will choose to deploy to a remote device. And I have no devices in my account, so we'll add a new one. We'll call it Pi 4, and then it's all the defaults at this point. So that come with the alwaysAI OS image. So it's pi at alwaysai.local. Cool, so we're connected and we're in and setting up the device for this app. And yeah, we'll go with the default installation directory. Okay, cool. Next step is to deploy the app onto the device. And so if you're running this for the very first time and you don't yet have the Docker image downloaded onto the device, it can actually take quite a bit of time to download that for a couple different reasons. One being that the Wi-Fi rates on these devices aren't usually super amazing. Just so we don't have to wait and watch it load forever, I already preloaded that too. So here we are, we're ready to start the app. So let's go ahead and do that. We should see a link come up once it loads. That'll help us get to the streamer page. And so here's the full list of labels that we're detecting. But if we remember, we were filtering only by the person label.
Hey, Eric, can you enlarge your terminal just a little bit?
Yeah, let me see. There should be a way to zoom in. Is that better? More?
I think that looks good.
Okay, cool.
Yeah.
Yeah, thanks for that. So yeah, so there's no one in the camera yet because I'm not over there, but I can take a look and we're seeing, this is just running on the CPU of the Raspberry Pi, so it's actually going to look kind of slow. And the 30 frames, when you're running this slow, actually lasts for quite a while. So it's going to hang, this detection is going to hang around for a minute. So we can see, we can stop it. We saw person 0 entered, person 0 exited. So according to our app, there should be an image that was saved for that. And let's figure out where that image went. So we take a quick look at our app directory. It didn't make it back onto the laptop. And that's because in this simple application, there's no synchronization between files that get saved on the device, such as log files, and stuff that gets carried back to the to your laptop or development machine. So there's a couple of commands we can use to explore what's actually in the app directory on the device. One being AI app exec, and this lets us run a command in the container on the device. So we can just run ls to list the files over there, and we have this JPEG file that we saved just a few minutes ago. Another thing we can do to work over there is AI app shell, and that opens a shell in the container in the Python virtual environment and everything. So we can kind of get the same ends there. But neither of these have helped us move that file over to my laptops. We just know it's there. So the easiest way to do this, since we're just going over the local network, is to just use secure copy or SCP. And we just put in the credentials. And then the install directory that we chose a little bit up here. And then let's get all JPEG files, and we'll just save them to the local directory. So cool. We've got our JPEG file moved over, and we can just take a look at that. Let's see. So this isn't a particularly amazing photo because the way that the app works is that it grabs the photo right when the new entry is discovered, right? And if you think about that for a moment, you might realize that maybe that's not the best way to do it. It's probably better to wait until more of the person is visible and they're a little bit later on. So maybe you could write a more sophisticated app that collects a few images over the duration that the person is in the frame, and from there chooses maybe the best one, or maybe saves a couple pictures of each person depending on what your goals are. So this app is just a very simple way to kind of get started with that. So cool. And I guess there was one other thing that I wanted to show real quick. It'll only take a minute. To get better performance out of the Raspberry Pi. Some of you may have heard of this or already using it, but I have a neural compute stick from Intel, and this is just a USB stick that we already have support built in EdgeIQ. So what you can do in your app is just edit one line. Here we go. We'll run it on the OpenVINO engine, which is the engine that works with NCS2. And we'll just deploy this app out now that we've made a change to the source. And we should see much better performance this time when we run it. We'll give it a minute. Cool. So we can just refresh this page. And we were seeing, I think, around 0.3 or 0.4 seconds of inference time before. Now this is pretty blazing fast. I mean, as I walk around, it tracks me really closely now, and it doesn't look too delayed. So, I mean, considering, you know, the Pi is like 35, 40 bucks, and then an NCS, I think, is 70 or so dollars. It's pretty good performance for a low-cost combination of things. So, yeah, so that's what I had lined up to show, and I think we'll take more questions now.
Eric, we have a request from Steve to show if you if you can blur the face on this app.
Oh, to like add that in? Yeah, let's do that. So we'll have to do a couple things, because right now we're detecting an entire person, not just the face, right? And on top of that, we will need to take the face that we've detected and then blur it. So this app itself might not be the best starting point because it has a few other pieces in there, but I'd be happy to kind of go through. I think we can work with the real-time. I think we have a real-time face detector, and I can add blurring into that if we're interested in going through that process. Does that sound good, Komal?
Yeah, sure.
Cool. So let's see. So you can get, so we have in the project pathway, we have a couple of starting points. We have a wider selection of starter apps if what you want to do is outside of those options. And then type it correctly using the, can't have them already downloaded apparently. So we'll download them, and then in here we have I think we have like a face counter, or there's face counter. Let's see, real-time facial detector. That's the one I wanted. So let's just take a look at what this app is doing. So the model we're using is this Res 10 300 by 300. We can get more info on that in the model catalog. And then from there, we're detecting the faces, marking up the image. So let's just try and run this one first and just see what it looks like. Make sure it's actually working, right? That was a good first step. So we'll start from scratch again because we already have the app. Cool. We'll go through the same steps that we just went through previously. So now I have this face detector. We'll run it on a remote device again. And I already have this device set up, so I can just select it again. And while that's going and installing the model, let's dig around the docs and figure out how to blur. I think that it's an option. I think it's in the tools, actually. So let me see. We have some tools. And we have, there we go, blur objects. So I think that'll be the tool that we'll want to use. Let's see, yeah, it takes an image and then a list of predictions, which will be the faces. Yeah, looks pretty simple. So let's give this a try, see what it looks like, and then we'll add blurring in.
So we have a couple of questions, Eric, while this installs.
Sure. Yeah.
So the first one is, can this app also record video as well as snapshot when an intrusion is detected?
Yeah, so this app isn't set up to do that, but we do have tools to record video. We have this module called Video Writer. Let me get this thing out of the way. Put it over there. And Video Writer enables you to record video clips in any way that you want. So when you want it to start, when you want it to end. And then if you want to build it into your app a little bit like in a more integrated way with handling events, we have Event Video Writer, which you can basically trigger it to start and stop, and it handles a lot of nifty cases like a pre-roll and a post-roll. So in the case of like a break-in or something, you might be interested in what happened in the 5 minutes before the break-in started. So you can put in a like a pre-roll timer, and whenever the event occurs, it will also capture what happened in the that many minutes before the event happened. So some really cool stuff in the area of like security that you can do with the Event Video Writer. And I've worked a little bit on it too, on kind of a standalone security camera app. That I don't think it's up on GitHub yet, but we've been messing around with it for a little while to kind of like build out these features. So, so yeah, I think that covered what you were asking, Komal, right?
Yes, awesome. Thank you.
Cool. And then let's go back to blur object. So we'll see this. Okay, so let's see if it gets my face. So yeah, there we go. It's got my face. Move around, it's going. Okay, so that works as we expected it would, which is great. And now the step is to add the blurring in. So what we're doing is we're sending, so we get our detection results here. And what we're doing after that is we're marking up the image with those results. Additionally, let's see. Additionally, so that's so the markup image puts the bounding boxes and the label and stuff like that. So we'll want to do an additional step after where we blur the objects. And we might even want to do it first, just so we don't overwrite. Yeah, let's do it first, but I'll just finish typing it out. So what I'm worried about is overwriting something that we've already put, like maybe it'll blur the boundaries of the bounding boxes or something in this case, which we wouldn't really want. So blur objects, and then, yeah, so image, frame in this case, and our predictions. And one thing we might also want to do is actually just skip putting the bounding boxes there altogether and just have it blur my face. So let's see if that works. Steve's really putting me to the test here.
He apologizes for that.
This is a good one, though. This is, yeah, people have definitely asked about stuff like this before, so it's a good use case to show. Where did my tab go? So let's see if this worked. Oh yeah, look at that. So that would work really with any detected objects. If you wanted to blur my entire body, it would work with that as well if we were using the person detector one. But in this case, like you saw before, the bounding box is just around my face, so we just got blurring around the face. Cool. So what else do you have?
So the next one is, does the choice of camera matter in these projects, USB versus a CSI camera?
Yeah, so there's a couple things that we've seen, and so there's a couple things to consider, and that's one is that the quality of the camera and ability to handle different lighting conditions and stuff will make a difference. A lot of these models are trained on generally good lighting conditions and stuff like that. It may not handle like darker lighting. Even in my office here, it's a little bit dark, so some of the models perform a little worse sometimes. But beyond that, depending on the way your device is configured, I'll give an example. But depending on the way your device is configured, you may see better frame rates out of a CSI camera instead of a USB camera. And one example we saw is on the Pi 3, the Pi 3B Plus. The USB ports all go through the same bus. And so what we were seeing is if we were using a USB webcam along with the NCS, they would compete for bandwidth, and we'd actually see a slower performance overall. When we moved to a CSI camera, that freed up bandwidth on the USB ports to kind of maximize what we were getting out of the neural compute stick. So in cases like that, it does matter. Yeah, as far as like what we use the Pi camera module all over the place on nanos as well. So we get a lot of use out of that. And then we messed with some other cameras that have like infrared abilities to kind of see in the dark a little bit. A lot of models, if you want to get into that for security cameras, you probably want to train a model specifically on it. Some of these general models we have might not perform super well on that. But yeah, I think that covers it.
Yeah, thank you for answering that. So we have another question here that says, does Edge IQ also support RPI Noir camera?
I'm not sure. Yeah, I don't know if I know what that camera is. So yeah, maybe I'll look into it if you can note that down.
Okay. So AB, we'll reach back out with that question, the RPI Noir camera.
Oh, the Raspberry Pi Noir camera. Sorry, we do support it, but that comes back to whether or not the models perform well on it. Sorry, I misheard you earlier, Komal.
Oh, all good. It's an infrared camera, it seems.
Yeah, yeah. So I've messed around with it a little bit. I wouldn't say that we've done extensive testing on how the models perform on it. We're not doing as much, what would you call it, like benchmarking in terms of the accuracy of the models, because it's so application specific. You might have different lighting conditions, so we could show that, you know, a model works really well with this camera, and you could go and run it, and it might perform poorly just because your lighting conditions are different, things like that. So we haven't done an extensive benchmarking on the accuracy of the models with those cameras, but as far as like, can you use them with our stuff? Absolutely. And if there's a camera that you're interested in using, reach out to us and let us know, because we're always adding support for more cameras and stuff like that.
Cool. So David asked if you have to have a Movidius connected to the Pi, and is the Pi running Raspbian as the operating system?
You do not have to have an NCS connected to the Pi. The Pi 4 is actually decently capable. You're not going to get anything close to what you would expect out of like a regular camera. So, for example, if the camera is running at 30 FPS, we saw that the inference time, or even here we have an example. Inference time is, in this case, like 0.3 seconds. So you're only going to see like, you know, a few frames per second in this case. We were seeing about 3. And when you plug in the NCS, you can bump that up a little bit more. This facial detector app wasn't using the NCS, so we didn't see the bump here. I would say that compared to the Pi 3B Plus, the Pi 4 actually feels like pretty fast, even without the NCS. So if you're, depending on which Pi you're on, it makes a big difference. And I think if you need something to be refreshed at a super high rate, if you need something that's closer to like 15, 20 FPS, you have to go in the direction of an NCS or start looking at other boards or other accelerators. So, and I think there was a second part to your question, right?
Yeah, is this running on the Raspbian operating system?
Oh, so this is running on, it's essentially the same, but they've renamed it to be Raspberry Pi OS. So that's why I didn't mention Raspbian earlier. Yeah, so this is running on the latest version of Raspberry Pi OS, which is the renamed version of Raspbian, with a few additional configuration changes that I mentioned earlier to kind of speed up your process to get it up and running as an edge device.
Cool. Is it possible to test the same project in platforms with mobile camera?
As in like, sorry, can you, are there more details or?
No, actually, Mohib, is it okay if I unmute you to further elaborate on your question? Mohib, you should be able to speak now. Let's see. Okay, let's give him some time. Maybe he's not ready. The next one is, are you working with encoding video format or with RGB frames?
So all of the inferencing that's happening, so that's whatever we're doing with the neural nets on the CPU and in the NCS. Actually, I guess I can't speak for exactly what's happening in the NCS, but I'm fairly sure that it's RGB data that's what we're passing in. I'm assuming that's what they're doing it. So this is not working with encoded video data. I'm not really sure. I haven't run into any cases. There may be models that are actually trained on video data. All of these models that we've looked at are called single shot detector. Well, not all of them, but the ones we've looked at are single shot detectors, and they run in a kind of a one go on a frame by frame basis. So yeah, so they're not really looking at multiple frames at a time. That's kind of where the tracker came in. That's how we could bring in information across multiple frames. The model itself was just looking at a single frame each time. If that makes sense.
And then we have David here. He's actually a developer advocate from Buehler, if I'm not mistaken. Yeah. And he's asking, have you had any, quote, USB disconnect issues with running in the container? And he's saying that on my Pis within a container, I get a lot of trouble when the NCS re-enumerates.
Yeah, so I feel like we used to see that issue a lot more. So what happened is, I think we moved to a newer version of the firmware that was part of OpenVINO, and those problems pretty much disappeared. So I don't know which version David's on. If he's on the latest, then it could be a different issue, but we did see dramatic improvements when we moved to their latest firmware release. And that was even a couple releases ago, I think. So
yeah, David, would you like to elaborate on your question a little bit? You're welcome to speak if you like. I've given you, yep, he's on.
Yeah, can you hear me?
Yeah, hey.
Yeah.
Oh, hi guys. Yeah, sorry, I was listening along. I did have to drop for a couple of minutes there, so I apologize that I missed that you were running on Raspbian. So I get lots of USB disconnect errors, exactly like you're referring to, Eric. And that is running current code as far as I am aware, so I'll have to go back and double check. But of course, in my particular case, I'm running it atop Buehler OS, not Raspbian OS. So maybe I'll have to do some poking and prodding around in there.
Yeah, I feel like I did hit those issues too when I was. A lot of things kind of coincided because I was spending a lot of time actually working on an app that was running on Buehler when I was working with the NCS stuff at the same time. So it's a little hard for me to separate like what the issues were due to because they all kind of got resolved at the same time. With the USB stuff, but there's definitely some like trickiness with their USB driver in terms of it re-enumerating and stuff like that.
Yeah, so it starts out in there's a custom ASIC inside of the NCS stick, and when you go to essentially begin your AI algorithm, like when you begin to run your workload, it switches from the it might even be like an MCU over to the NPU. It gets pretty detailed from what I have read, but anyways, I have struggled with it immensely. And I know that you have your support Discord, so if you don't mind, may actually want to pick your brain on that a little bit.
Yeah, that sounds good.
And David, if you're not on Discord already, I'll send out the link as well on the chats.
I'm in there.
Oh, okay, perfect. Does anyone else have any questions? Feel free to raise your hand. I know we're running close to the time here, but happy to take any questions that anyone might have. Okay, we have one from Leonardo. Hey, Leonardo.
Hey, hi, how are you? Can you hear me?
Yeah, hey.
Okay. So I was wondering, so we have of course this vision on what we want to do with Always AI, and that's why, sorry, my questions might be, they're very focused into that, into developing some applications and on very specific user cases. And one of the things that I really never saw addressed or discussed is how Always AI might be able to handle not only those little small cameras, I guess we're using the webcams on our machines and some small Logitechs, but connect the system to a full-blown camera system on an existing location where we might have full HD cameras, sometimes 4K cameras. So the amount of data, of course, is way bigger than what we have been doing on those little cameras, and how the system, from a hardware perspective, would be able to handle this massive additional amount of data to process those images.
Mm-hmm. Yeah, that's a really good question, and I think it's a little bit of a space that we haven't fully addressed yet, but we've definitely kind of had our eye on it, and so it'd be, if you're on Discord and stuff, we can kind of continue chatting there. But a couple thoughts that I have in my mind as we speak are that we do have like an x86 Docker container. And so if you're running on a more powerful server instead of a Raspberry Pi, you could build out basically kind of a whole distributed computer vision like container orchestration thing where, the container could, you could have a container for each video feed if you wanted to, something along those lines, and kind of, I guess you'd still need another app to kind of bring all the data together however you wanted to do that. But that would be like one thing that pops to my mind that you could certainly do. It really depends on if you want, as you probably know, you can build your app out a few different ways. And the apps that we've shown so far are kind of like all enclosed apps that handle the computer vision, and they have a browser, like a HTTP server that comes up and all that. But really, in a more complex app, the computer vision part will just be one small component. And so if you want to just build the computer vision piece into the EdgeIQ Docker container, you can build that into a larger system with containers doing whatever other pieces you need, and kind of go from there. So I don't know if that helps at all, but I'd love to talk to you more about that, because we do have our eyes on enabling more use cases like that.
Okay, fantastic. Thank you.
Thank you.
All right. Thank you, Eric. And thank you so much, everyone, for attending. Again, we're going to do this every Thursday. So bring your questions, bring your feedback, bring your snacks, whatever it takes. And we're just super excited to get this rolling and like really engage more with the community and hear from you. So I noticed that a lot of you use the Q&A button, but like you're also totally welcome to raise your hand at any point. We invite conversation. So super happy that everyone was super interactive here. Just a couple of announcements. So we are hosting a model training webinar on August 26th. I'm gonna send a link out in the chat to all attendees here. So just go ahead and click on the link and register to attend the webinar. And in that webinar, you'll learn how to train your own computer vision model and deploy it to an edge device. And we'll see you next week, hopefully, for Hacky Hour. And again, if you have questions, feel free to reach out. Feel free to reach out to Eric. We're all available on Discord, super active there. The link is also available in our chats here as well. And I think there was an interest in seeing the recording for this, so I can go ahead and share a recording for this. This is being recorded. And with that said, I just want to thank everyone for joining, and I'll see you guys next week at Hacky Hour.
Yeah, thank you so much.
Yeah, thank you, Eric. Bye, guys.